then have the education knowledge based, not the number based. If you can gather knowledge, then number will come. And research, if you want to take research as a career, it doesn't matter which subject. You
Yes,
have
yes,
to understand the basics at the very deeper level, and always you will have some kind of mind which will raise the question why and how. This type of question you should have in your mind. In science, do not trust everything unless it is defended by some kind of mathematics or some kind of rationality. Okay, so learn the basics very well. Once you learn the basics, then you can get your knowledge at the higher level very easily. And do not make your mind from the very beginning that in my life I will do only mathematics, I will do only theoretical physics. Do not make your mind like that. Keep your mind very open, look for everything,
yes, sir.
and continue to study. And at certain level, you will see that where your interest is moving, what kind of understanding is driving to that direction. Either it is experimental physics, either it is theoretical physics, something like that. So do not close your mind from the very beginning. Do not decide that I am born for theoretical physics or I am born for experimental physics. Don't do that. Study everything properly from the very basic level, and keep your mind, keep your eye open, and look around
Yes.
what is happening around the world in that field.
So, what advice would you give to the students for applying research position at your institute like TIFR?
No, here advice is we have very standard procedure. We conduct the exam in December. I think already the form submission has started. So we take admission test, our graduate studies admission test in December. Then after written test, we also call for interview. And after interview, we select certain number of students. So if you want to join TIFR, you have to follow the route. Or not only TIFR, there are also various other institutes in India, like IISc, Indian Institute of Science, Bangalore, various IISER, NICER, and various other institute in very research institute in all over India. So they take the students through the GEST. So you see that when the GEST exam takes place and you go through that route, and according to your interest and convenience, you join an institute and your of course your likings.
Yes, sir. So, how important is programming and data analysis in this field?
There is no alternative. It is very, very important nowadays. Very, very important. Programming and data analysis is a new thing. There is, whatever
Yes,
we
sir. You
do,
just saying yes,
data
yes, sir.
analysis. Data analysis is not, you cannot say that data analysis, data people are analyzing data. We have been, we are people in our field, they have been analyzing data last 100 years. So data analysis in our own terms is not the new thing, but the way the data analysis is done, which this data analysis term is really coined by some, I don't know, from software world or corporate houses. But thing is that in research, we always do the data analysis. Now the question is, in order to do the data analysis, what kind of tool we use it? So, and recent tools are, of course, the machine learning. And yes, these are all things you can learn it. And these are, but one thing you remember, the software and the programming and all these things, this is our tool. We use this tool to do the physics.
Yes, sir.
Okay. So you have to learn. You have to learn the tools. For example, if you work in some kind of place where you have to use some kind of mechanical tools, if somebody works in the garage, for example, either you are trained or untrained. If you work in the garage, you have to understand all the tools and the use of the tools. Similarly, here we have to understand all the tools. Without understanding all the tools, nowadays it is very difficult to do the physics.
Yes, sir. So now other query that what are the opportunities for the Indian students to collaborate on international physics project? Just explaining
There is
our
opportunity. It doesn't matter. When you are as an MSc student, there is no, you cannot have that kind, any kind of window to collaborate with. But whenever you will join some place to do your research, which you like it, then of course you can work with the foreign universities, foreign institute. You can have the foreign collaborators. There is no rule or no prevention, nothing. It depends. If you get the opportunity, you can work. It is up to you.
yes, sir. Now go ahead to the other topic that funding and research ecosystem. So can you discuss the challenges and opportunities for securing funding for high energy physics research?
Funding is there. The high energy physics is mainly funded by the Department of Atomic Energy in India and Department of Science and Technology. So
Yes,
they
sir.
fund it. If, for example, we are involved with the various mega science collaboration in India. About how many institutes? 12, 15 university and institutes, they are involved with the CERN collaboration. Those are funded by Department of Atomic Energy, Department of Science and Technology. So funding is there, but it is, as you know, it is always there. How whatever money you will be asking from the government will not give that amount. Government will do certain kind of calculation in their own way, and they will give some funding. Funding is there.
Yes, sir.
Funding is there. I think at the student level, my advice is that you need not to worry about the funding, etc., because you are not at the stage of deciding any policy or any planning. You are at the stage of doing PhD. So better you don't bother about that. You just learn whatever opportunity you will get it. You just try to go through with that.
Yes, sir. You just saying the CERN. So what role do large scale collaboration like CERN play in advancing global research?
Very much. As I said,
Yes, sir.
technological development, it is a huge. And CERN is basically, you can say that it is the Mecca of the particle physics. Okay.
Yes, sir.
So their impact in technology development, their impact in physics, their impact even the society for various other aspects, it is a huge. It's huge.
Yes, sir. So how can young researchers overcome resource constraints in developing countries?
It's a difficult question, man, unless you say it very specific. See, government is there to help, but it's not that you go to the government will immediately give you money. You have to write down a project, you have to make your plan properly, or you have to convince the funding agency, you will get it. And there will be some difficulties everywhere. These difficulties will be there. You have to
Yes, sir.
just overcome it.
Just go ahead, other our most important thing that personal motivation and philosophy. That's in this category. Just what motivates you to continue pursuing research in high energy physics?
Motivates is you have to have some kind of passion for science.
Yes,
Whatever
sir.
you do, you love this science, and I think it is a passion. Your passion and your love for science, which if you have it, then you will do it. I see many students, they just leave the IIT and they come for physics. They come for chemistry, biology, because if somebody gets chance in IIT, IIT Bombay, IIT Kharagpur, IIT Kanpur, and after their 4 years course, after they complete their BTech degree, then they may get very easily job in very uh, good organization, good corporate sector with a fat salary. But
Yes,
in spite of that, those we have seen in TIFR, very good number of students, they just left their IIT in the middle. In the middle, they leave IIT. Even after getting a BTech degree, they come for physics. They want to do
yes,
physics because they want to explore, they want to cultivate, because they do it because they have the very special kind of passion and the love for the science. I think that motivates students to do that.
yes, sir. Yes, sir. Thank you, sir. Now, how do you manage setbacks or unexpected result in your research?
No,
Because I just
sometimes
saying because yes, students also doing research in your
no,
field.
no.
So
This is for students. I'm telling, this is a field. This is the area. You may have lot of hurdle. You have to struggle a lot. It's not that, as I said, if you join IIT after you complete your IIT degree, then very likely, high possibility that you will get a job immediately somewhere. But in this area, if you take this area, PhD and postdoc, so it is not very easy to get it. You have to struggle a lot. But I feel if you have a passion for science, if you love science, you do hard work, continue to do it, keeping your goal fixed, and you will achieve it.
yes,
I
sir.
can
Yes,
tell it from our experience. We will achieve it. But some things you cannot get it just like that. You have to struggle, but at the end of the road, you will get something. But important thing is that you have to have that kind of love for the science, that kind of passion for the science. You can do that.
yes, sir. According to your area, so what do you enjoy most about working at TIFR?
No, TIFR TIFR is very much enjoyable. Here the atmosphere is so professional,
Yes,
and facilities are very unique, very nice, and cooperation from the institute, everything. I think what TIFR gives to us, we are happy with that.
yes,
People
sir.
are working here. Whatever they get, they get it. Almost they get it.
Yes, sir. Now, next query that how has the field of high energy physics evolved since you started your career?
It's very fast. I started my career that time. Standard models, few particles were not discovered. Then those particles were discovered. Important is that top quark was discovered, and the standard model was tested very precisely, very precisely. And precision is at that level so that people do not have any kind of doubt about the standard model, only other than the presence of the Higgs boson. So after that, Higgs boson is also discovered in 2012, and then everything is fine. And I saw the lepton lab collider, electron positron collider at CERN, then proton antiproton colliders at Fermilab. Then I saw that electron proton collider at Daisy Hamburg, and then this 2010 or 2011, the proton collider started and discovered the Higgs. So the huge kind of development took place as far as particle discovery and the technological development and the software development.
Yes, sir.
So I have seen a lot. And also the computer. When I started working in computer, that time we had only a very small PC.
Yes, sir. Yes.
which is called the personal computer, PC. And with say hard disk was how much? 500 GB, even less. That kind of hardware availability we had that time. Now we are here, we are working in clusters. Okay, and even that our desktop, even the laptop, those are very powerful to work. So huge development, technology, science, and computer.
Yes, sir. Yes, sir. Our last topic, that future prospectus and vision, that what future developments do you anticipate in high energy physics?
Future development, which I anticipate, is, as I said in the very beginning, we are looking for the new phases. That is the ultimate thing we are established, because the high energy phases people, the coming, the idea is that, belief is that,
Yes, sir.
our intuition is that there should be a single theory which is called the grand unified theory. So grand unified theory, which will describe all the four forces at the scale where we belong here. That is called the Higgs scale or the electric scale. So if we, that is the ultimate achievement, ultimate goal we have. The high energy physicists are having that kind of aim. And so for that, lot of hurdles are there. We have to overcome step by step. And for that, we need to have the experiments, whatever we have today, and whatever energy we can access today, we have to go for more and more higher energy and more new technologies and the new softwares to cultivate that area, to explore that area. And people are, the community are already, international effort is there already to build machine. Various proposals are in place. People are working for it. And next, if everything goes fine, then maybe in 2050 or 2040, 45, some new machine will come with very high energy.
Yes, sir.
And we'll see
Yes, sir.
what
Fine, sir.
happens finally.
Yes, sir. You just explain your long-term research goal. Now, how do you envision your work contributing to the broader scientific community?
The broader scientific community, if you ask my work, I will not say it is not there. This, whatever I have worked, that is useful for our community. But
Yes, sir.
broader community, I do not see that kind of effect. Whatever we work in this area.
Yes, sir. Yes. So our last part, that advice for students and scholars. So what are the common mistakes students make when they starting their research career?
As I said, don't keep any gap while you are understanding the subject. Learn each and everything from the very basic. This is important thing. This is the mistake you have it. Sometimes when we read it, we prepare for the exam. We say that, okay, chapter 1, chapter 3 is important, chapter 2 is not that important. Okay, last year question came from chapter 2, so this year it will come from chapter 1 and 3 and so on. So ignore chapter 2.
Yes, sir.
Avoid this kind of approach. And this is, as I said, don't go with the number-based education, go with the knowledge-based education. And the number-based education, most of the coaching centers, I think they teach that like that. But you learn something on your own, keep your mind very open,
Yes,
and
sir.
don't keep any gap, whatever you are learning. It is very
Yes, sir.
important.
Yes, sir.
There is no easy way of learning the things. You have to do very hard work. And I believe if you do the hard work, you will be awarded one day or the next day.
Okay, sir. Fine. So how can students better manage their time and energy between research and the coursework?
No, no, no. When the coursework is there, then there is no research.
Okay, sir.
Coursework is to just groom you for the research. When you do the coursework, you just do the coursework. Don't mix up the coursework and research. It is not designed that way. Coursework is a subject mentors, instructors teach you, you learn it. At that time, don't think about doing the research. You can keep information, you can gather information, who is doing what, but don't mix it up. At least in TIFR, we don't allow that. While doing the coursework, you also do the research.
Yes, sir. So that what are the key resources like books, journal, or software you recommend for students in your field, high energy physics?
Now, many things are available openly in the internet. So when you are a student, I do various student will have the various kind of interest. So difficult to give any generalized answer. It is a very specific, case specific.
Yes, sir.
There is no very general shortcut answer of it.
Yes, sir. So now that the career development and networking, so how important is networking for researchers in their academics?
Networking means in what context you are saying?
Networking means that I am just saying that networking means many collaboration for many researchers or many faculties or scientists. Network.
So here
Just
you don't have to nowadays because of this fast connection with the world,
yes, sir.
any corner of the world. You can work with various people, you can collaborate with the various people. If your subject, if your research requires it, then you talk to the people, you establish a network. I don't call it a network, I call it the collaboration. So it is important.
Collaboration is very important for the research.
Yeah, if you want to really enrich your knowledge.
Yes, sir. Yes, sir. So what role does publishing play in establishing a successful research career?
If you do research, you have to make your results public. So that is a publishing. It is a integral part of your research.
Yes, sir. So how can young researchers build meaningful professional connections in academic?
So as I said, this is the same question as you have asked regarding the network, uh, which I rephrase it as a collaboration. It is very useful. It is very useful. If you have something to share, if you have something to learn from somebody, you get in touch. Now world is, it has become very small. Everything is at your hand. So start collaborating and it will be very helpful.
Yes, sir. So how should students approach learning complex theories in high energy physics?
So if you say the which student, I don't know. Is it the MSc student? Is the research student?
Sir, you just explain for MSc students and scholars.
No, MSc students, whatever are being taught in
Just
your
advise
university
use.
college, you just learn it there. As I said, again the answer is same. You just learn what is being taught in your classroom and learn it with keeping any gap. Learn it from the basic. Don't ignore any basic things. Sometimes people don't understand the minimal things, the Heisenberg uncertainty principle, but they think various high level issues in the quantum mechanics. Don't do that. So
Yes,
learn
sir.
everything at the very basic level, step by step.
Yes, sir. So just conclude and remarks our conversation, one or two line in your word.
So my advice to the students, if you love for science, if you have the passion for science, it does not matter which science, and you learn it from at the very basic level, and put your 100% effort and concentration in that area, in that topic or subject, and don't think about what will happen if you do this in future, how much salary you will get it,
Yes,
etc., etc. You just concentrate your work, do the hard work, and you will be rewarded. And it is true with all the field. It is true with the science. And other thing is that if you do the science at the BSc or MSc level, I think you are immature, because do not decide at that level that you will do the experimental physics, you will do the science what the NASA is doing, you will do the science what um, um, high energy physics they are doing. You try to gather information at your level, then slowly you decide your mind what you will do. Do not bias yourself from the very beginning that you will do the experimental physics or you will do the theoretical physics. You come, you see what is happening, which area it is happening, what kind of things. Then you will see that one or two areas will attract you.
yes, sir.
Okay, maybe theoretical physics, maybe experimental physics. Then you just slowly move to that direction. But from the very beginning at the MSc level, where when you were very matured, in most of the places, I think most of the places you do not have that kind of exposure, the research in experimental physics or theoretical physics. So that's why I'm saying don't be biased like that, because I have seen in TIFR when students come at the day one, they say that no, I have come here to do the theory physics. Personally, I feel don't be biased like that.
Yes, sir. So finally, I conclude that Professor Mojumdar has nicely explained the career path and motivation, field area and research focus, diversity, opportunities and directions, funding and resources, guidance for aspiring researchers, challenges, interdisciplinary collaborations, career development and networking, research scope, application and implementation, and also social impact and expansion, and also give nice advice for the students and scholars also. So, sir, thank you very much for giving this interview for the benefit of the students, BSc, MSc, and also the research or PDF also. So, thank you very much, sir, for spending your valuable research time schedule to give this interview for the benefit of the students to pursue research as a career. Thank you, sir.
Okay, thank you very much for calling me and giving me chance to share my thought with you guys. Uh, who are very younger and thinking, pursuing the research in their life is most welcome. And wish you all good luck.
Yes, sir.
And do not hesitate to contact us, to contact me for any kind of suggestion or guidance. Not only me, anybody in TIFR, we will be very happy to help students for any kind of need.
Yes, sir. So my own opinion is that I am just a master student. So basically, I am not interviewed you. It is just the discussion for the benefit of the students to pursue research as a career. Yes, sir. Thank you very much, sir.
Okay,
Thank
thanks.
you, sir. Thank you, sir.